Hmm.
Yeah, down below once you purchase so I can upgrade that shipping as well. Okay, for absolutely new and pediatric facility.
Hello. Just gonna wait for a couple more people to hop on. If you're joining from TikTok Live, I am having technical difficulties. So if you want to go ahead and join the YouTube Live, you'll be able to see me share my screen and work through practice problems. I'm going to drop the YouTube Live link in the TikTok chat so you all can join on YouTube Live. And then we'll get started on some practice problems. Hello. If y'all want to tell me what your name is and where you're joining from. Nice to meet you, Ahmed. We're just waiting for a couple more people to join. Since you're joining from TikTok, I am having some technical difficulties. So if you want to go ahead and join on live on YouTube, you'll be able to see me share my screen. So I just dropped the link to the YouTube Live in the chat. If you want to use that. Are you a college student, Ahmed? Hey, Tyler. Hey, Sam. Just waiting for a few more people before we get started. We'll probably start to work through practice problems around 3:05. Ooh, good luck, Tyler. Are you a civil student? Nice. I'm sure you're going to do a great job. So I am having technical difficulties on TikTok Live. So if you guys want to join on YouTube Live, you'll be able to actually see my screen and see the practice problem that I have up. So I dropped the link to the YouTube Live in the chat if you all want to use that. I don't think I see anyone on YouTube Live yet. This is my first time going live on TikTok and YouTube. So stick with me. Awesome, graduating in December. That's super exciting. Do you know what you're going to do next? I know the semester probably just started for y'all. Let me know when you all are able to join on YouTube Live so I can make sure that it works. Hi, Drew. All right, we'll get started working through some practice problems here in a minute. Just giving everyone time to log on the YouTube Live. All right, it's 3:05, so I'm gonna go ahead and get started. Will this be recorded? I will. This is my first time streaming to YouTube, so bear with me. I'm going to start recording, I believe, and if I get this right, I will post it after this session. But yeah, thank you guys for joining. This is Degree to PE's first ever live FE exam study session. So just wanted to start these because I know the college semester is probably starting for a lot of y'all. And if you're planning to take your FE exam this semester, we'll have these every week so you all can get refreshed and ask questions, any questions that you all have. Um, there's a link to a Google form that you all can fill out if there's ever any questions that you all want me to go over during these lives. I'll be going live every Wednesday and Thursday from 3 to 4 p.m. Central Time. And yeah, today's our first session. So, yeah, can you all see my screen? Like, can you see me as well as the blue background on YouTube live? All right, I'm going to assume that you can. So let me go ahead and switch screens so that we can actually start going over practice problems. So down here, I have my iPad, which I'll be writing on, and then I'll be toggling between the webcam and my iPad. If you're joining on TikTok, unfortunately, I'm having technical difficulties. So if you want to join on YouTube Live, you'll be able to see the practice questions. But yeah, let me go ahead and switch over to my iPad so we can go over our first practice problem. So on my TikTok page and in the future on YouTube, I will be posting short form practice problems. So we're going to go over 4 problems today. If you all want to go ahead and try to get started on this one. So not sure where everyone is at in their FE exam study. Feel free to let me know in the comments. But I was planning on just letting you all try to work through the practice problem yourself for a couple minutes. On the FE, you basically have 3 minutes to do each problem. And so, yeah, I'm gonna set a timer for 3 minutes, let you all try to walk through this. And then after 3 minutes is up, we're gonna see if you all got the answer right. And I'll show you all how to do it if you're having any difficulties. But yeah, this is the first question. Number 17, a tractor costs $7,500. After 10 years, it has a salvage value of $5,000. Maintenance costs are $500 per year. If the interest rate is 10%, the equivalent uniform annual cost is most nearly what? So this is an engineering economics problem. So you're going to need to have your FE handbook handy, which you can just search up online. The reference manual has all of the equations that you'll need on the exam. So get used to having it right next to you. I have it pulled up on one side of my computer so that we can work through it when you all are ready to do that. So I'm going to start a timer for 3 minutes and let you all try to work through this. And if you have any questions, feel free to drop them in the chat. Let everyone know where you're from, what your name is, so we can all get to know each other a little bit better.
Introducing Taco.
All right, 30 seconds have passed. So hopefully you're getting your bearings on how to do this problem. You have a piece of paper and a pencil and you're working through it. All right, you guys have about a minute left. Anyone have a guess at what the answer is for this problem? Feel free to drop it in the chat before we walk through it. All right, about 30 seconds left. Any guesses to what the answer is for problem number 17? You have a 25% chance of getting it right. All right, 10, 9, 8, 7. Okay, pencils down. So yeah, let's go ahead and dive in to see how we're supposed to solve this problem. So, like I said, this is an engineering economics problem. Let's go through the problem and see what information was given to us. That's a strategy that I like to use for the FE and PE exams. First, just understanding what the problem is asking for, the information given, and seeing what we come up with. So it says a tractor costs $7,500. So that's going to be the present worth of the tractor. So present worth equals $7,500. After 10 years, it has a salvage value of $5,000. So what that means is in 10 years after you sell it, it will be worth $5,000. So that's going to be a future worth. So future worth is represented by the letter F. It's going to be $5,000. The time frame we're also given is 10 years. So we know that in engineering economics, N represents the time period. So N equals 10 years. The maintenance costs are $500 per year. So that is an amount you're paying each year to maintain the tractor. So that's going to be an annual cost represented by the letter A. A equals $500. If the interest rate, so if I equals 10%, the equivalent uniform cost is most nearly what? So let's go ahead and draw this out in a timeline so we can see what exactly is happening in the situation. So if this side here is time 0, I'm going to make a mark for each year. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so any amount that is that we are paying for, we're going to put on the bottom of the graph, and if we're getting money, we're going to put it on the top of the graph. So what do I mean by that? So it's saying the present worth of the tractor is $7,500, which means we paid $7,500. So that's money coming out of our account. So I'm going to draw that as an arrow going downwards. The amount is 7,500. The salvage value is $5,000. So that's money we're getting back in our pockets after 10 years. So I'm going to put that here on the top side of the graph. That's going to be $5,000. Yes, cash flow diagram. All right. And then the maintenance cost, that is an amount that's coming out of our pockets each year for those 10 years. And that's going to be $500. All right. So the question is asking us to turn all of these values into an annual amount. So some amount that will come out of our account over the 10 years. So that's what we're going to do. Let me bring up the interest rate table. Hopefully you all can see this. All right. So we need to transform P and F into A values. The maintenance cost is already a uniform annual amount. So we can just leave this value as it is. But how do we transform a present worth into a uniform annual amount? So we do this by using our interest rate formulas. So whenever you are given a certain value, in this case, we were given the present worth, you need to multiply it by a certain factor to turn it into a uniform annual amount. So if we want a uniform annual amount, but we're given P, we need to find the A over P value for a time period of 10 years at an interest rate of 10%. So you multiply by A over P because obviously if you were to actually multiply this out, the P's would cancel and you'd be left with A. So that's why you're trying to look for the A over P value. And then we also need to transform the future worth value into an annual amount. So to do that, what do you multiply F by? What factor? Is it the P over F, P over A, P over G? Anyone have a guess? So if you want a uniform annual amount, you're going to multiply F by the A over F value. And again, the time period is 10 years and the interest rate is 10%. So we need to find the A over P value and the A over F value using this handy dandy interest rate table that you can find in the FE reference manual. So the A over P value with an interest rate of 10% and a time period of 10 years. Let's go ahead and find our N value. So this is our N value, 10. Ooh. Okay, that's better. So the A over P value is going to be in this column here. So the A over P value is going to be 0.1627. And the A over F value is going to be 0.0627. Does that make sense? Yes. Great job, T. Okay, so now that we've found our A over P and A over F values, now we need to multiply uh, them by their respective present worth or future worth. So let's go ahead and do that down here. Just trying to make sure you all can see. So the present worth is 7,500. The future worth is $5,000. So let's take this first equation, 7,500. We're going to multiply it by the A over P value, which is 0.1627. And what do we get? Let me grab my calculator. Anyone have any guesses to what 7,500 times 0.1627 is? All right, so I am getting $1,220.25. Please correct me if I'm wrong. And then we're gonna go ahead and do this second equation. So the future worth value, the salvage value of 5,000 times the A over F value, 0.0627. And what is that going to equal? So I'm getting $313.50. So again, please correct me if you're getting something different. But again, let's look at our cash flow diagram. So the present worth and the future worth are on two different sides of the graph. See how the future worth is up here, present worth is down here. We want to make sure that anything we are associating on each side of the graph has a different sign. So in this case, I'm going to make the top negative and the bottom positive. So we have a positive 7,500 times 0.1627. So that gives us a positive $1,220. But the future worth value here, that's going to be, so this is the AF value, this is the AP value. We're going to make this negative since it's on the top side of the graph. Does that make sense? Okay. So once we have that, we're going to add each of the values we were given together. So to find the total annual uniform amount, we're going to have a positive P plus the uniform amount we were given, which is this $500. So plus A, and we're going to subtract F. So $1,220.25 plus 500 minus 313.50. What does that equal? Anyone have a guess? All right, I am getting $1,406.75, which means the answer to this one is most nearly C. All right, who's still with me? Who got that correct? Did anything about this problem trip anyone up? Anything we want to go over before we move on to the next problem?
That is so bad. Let's go, John. W, man. It's an acquired taste. Yeah.
Sorry. This just started playing out of nowhere. Okay. All right. So if there are no questions about 17, we'll move on to the next problem, which is a statics problem. And I know everyone loves statics. No, this is everyone's favorite subject. So yeah, instead of letting you all run through this, let's go ahead and hop into it together. Again, just because I'm not sure where everyone is at in terms of what level they are. So, all right, problem number 18. The magnitude of the resultant of the three coplanar forces A, B, and C is most nearly what? So, we are given three forces and we're being asked to find what the resultant force is. What is the resultant force? The resultant force is going to be the magnitude is going to be the addition of all these vectors together. So how do we do that? So first we'll need to break each of these forces into their x and y components. And then we will need to find the magnitude of the resultant force by taking the square root of the x and y components. So let me go ahead and write this down so you all understand what I'm saying. All right, so we will need to sum up all the forces in the x direction. Oops. Then we'll need to sum up all the forces y components. And then once we have that, so the resultant forces x value is going to be the summation of all of the x components of these forces. The resultant y component is going to be the summation of all of these forces y components. And then once you have the x and y component for your resultant force r, to find the magnitude of it, so the magnitude of the resultant force, we will do the square root of the x value squared plus the y component squared. This is Pythagorean theorem because if you have an x value and you have a y value, the magnitude is obviously going to be the hypotenuse. All right, any questions about that? Cool, let's get started. So, let's go ahead and break forces A, B, and C into their x and y components. So let's start with force A. So force A has a magnitude. This represents magnitude of 5 newtons. It has an x and a y value. So we can break it up into its x and y value. But first we'll need to find this angle here. So this is the triangle that we're looking at. Let's go ahead and pull that out. If we rotate it, see if it lets me rotate. Oops. Okay. So we know that the hypotenuse of this triangle is 5. We're trying to find the x value, which is here. I just flipped the rectangle, or the triangle, and then the y value is going to be this component. It's a 90-degree angle. So we are trying to find this angle so we can determine what x and y are. AX and AY. Okay. So we know that this whole angle right here is 105. We know the first quadrant is 90 degrees, obviously. So this angle is going to be 105 degrees minus 90 degrees, which leaves us with 15 degrees. So this angle here is 15 degrees. So the x component for a, so a of x, is going to equal 5 times a sine or cosine. So I like to use SOHCAHTOA, if you all have heard of that before. SOHCAHTOA, which just tells you what sine, cosine, and tangent are. So stands for sine equals the opposite over the hypotenuse. Ka is the cosine, is the adjacent side over the hypotenuse. And the tangent is the opposite side over the adjacent side. So if we want to find the x component of a, we will need to multiply the magnitude 5 by what? The sine or the cosine? It's going to be the sine because a of x is opposite of 15 degrees. So we're going to multiply it by the sine of 15 degrees. And the y component is going to be 5 cosine 15 degrees. Let's calculate what those are. So 5 times the sine, oops, and make sure your calculator is in degrees. For me, if y'all can see this, I'm using the TI-36X Pro. So I can see that it says degrees here up at the top. But if yours does not say degrees, I believe you go to mode. So the mode button right here for those on TikTok. So yeah, you go to mode, and then that's when you can change it to radians or gradients. But we're in degrees, so we're going to stay in degrees. Exit that. So 5 times the sine of 15 degrees is 1.29 newtons if you're carrying your units, which you should be. And then 5 times the cosine of 15 is 4.83 newtons. All right, let's find the x and y components for B now. Let me go ahead and duplicate this page, and we'll just erase some of this. Okay, so doing the same thing, breaking B down into its x and y components. Does B have an x component? Can anyone tell me? It does not. It only has a y component, so you know it doesn't have an x component because it's not going to the right or the left of the y-axis like this or like this. It's going straight up. So b of x is 0, and b of y is just the magnitude of b, which is 2.12 newtons. And let's go ahead and solve for c as well. Similarly, it has a x component, which is 2.12, but it does not have a y component because it's not going up from the x-axis, so there's no y direction. Nice, America. It does not. Okay, so now that we have all of the x and y components, we can go ahead and find the resultant forces x component by adding all of the x values together. So b of x, c of x, and a of x. So I'm going to go ahead and do that right here. So r of x is going to be ax plus bx plus cx, which equals 1.29. Oh, also, let's talk about our coordinate system and if these values are positive or negative. So in the x direction, if we go to the right of the origin, so if we go to the right of the origin, we know our x values are positive. If we're going to the left, we know the x values are going to be negative. So I'm just going to put that here. If the x value is going to the right, it's going to be positive. Same thing for the y component. If we go up from the origin, we're going to have positive y's. If we go down from the origin, we're going to have negative y's. So we'll put positive as going up. So for the x component of a, it's actually negative 1.29 because it's coming to the left of the origin. And the y value is positive. For the components of b, there's no x component. Y is going up, so it's positive. C of x is also positive. So we just need to make sure that we make this negative 1.29 plus 0 plus 2.12, which equals, any guesses? Who wants to be the first person to get a problem right on Degree to PE's live sessions? Anyone have their calculator handy? Anyone good at mental math? All right. Anyone able to give me the x component for the resultant force? It's going to be 0.83 newtons. So r of the x component of r is 0.83. So that means we are coming this way. 0.83 newtons. All right, let's calculate the y value for the resultant force. So our y is going to be ay plus by plus cy, which equals ay is 4.83. By is, ooh, I lost my colors. Make this blue. By is 2.12. There's no y component for C. So what is the y component for the resultant force? It's going to be 4.83 plus 2.12. I'm getting 6.95 newtons. we have ry equals 6.95. All right. So again, just going to duplicate this page and erase some stuff so we can see. All right. So now that we know what the x and y component is for the resultant force, so again, we had a positive 0.83, we have a positive 6.95. So our resultant force looks something like this. Let me make this thicker. So this is our resultant force. All right. So the magnitude for the resultant force, which is what the problem is asking for, we're going to do the square root of our x squared plus our y squared, Pythagorean theorem. So the r x value is 0.83. We need to square it. 6.95, square that. Can anyone tell me what the answer is? A, B, C, or D? Any guesses? All right, so this comes out to be about square root of 49. So our answer is 7. So the answer for this one is 7. Any questions about that? So to summarize, we need to add the x and y components up, and then to find the magnitude, you take the square root of each of those squared, and then you have the magnitude of your resultant force. Alrighty, so we'll move on to 19. So this is my most recent video that I've posted. So if you all have been keeping up with my page on TikTok, YouTube, you've probably seen this. So question 19 is asking us to draw the vector polygon of the forces acting on the roller. So there's a heavy roller. We know that it's being held in equilibrium on a frictionless plane, AB, and we have this force F acting on it. So again, this is a statics problem. We see that we're told that this roller is in equilibrium. So what does that mean? That means that the sum of the forces, the sum of the forces in the x direction equals 0. The sum of the forces in the y direction equals 0. And there are no moments acting on this heavy roller either. So the sum of the moments about some point on the roller, we'll just call it A, is also equal to 0. Because if the sum of the forces was not equal to 0, that means that the heavy roller would be in motion. So just thinking back to Newton's laws. All right. Let's also talk about the plane AB being a frictionless plane. So in real life, we know that obviously if you take two things and you try to slide your top hand over your bottom hand, there's some friction there. But this problem is saying there is no friction. So there's no friction force that's acting on the roller. So that's good to know. But what other forces are acting on the roller besides force F? So this is an object in space. It probably has a weight, and weight is a force. And weight is always going to act in the direction of gravity, which is straight down vertically. So we know that this roller has a weight. So let's go ahead and draw that force. And then, ooh, let me scoot up so you all can see. All right. So we have the weight force drawn. And then we also know that every action has an equal and opposite reaction. So the weight sitting on the frictionless surface has another force acting upon the heavy roller. So that's, you're always going to have a normal force acting perpendicular to the plane. So what does that mean? So our plane AB is here. There's going to be a force acting perpendicular to it. I'm surprised that picked that up. Because that was not a straight line. All right, so we also have a normal force acting on the roller perpendicular to the surface. We'll call that force N. Are there any other forces acting on the roller? So it's on a frictionless plane, so we don't have a friction force. Are there any other forces you all can think of? No, I think we found them all. So how do you draw a vector polygon? You are just trying, so in a vector polygon, the head of one force needs to be touching the tail of the next force. So if we go ahead and draw this out over here, so we have F, the force F. So the head, which is the arrow side, needs to be touching the tail of the next force, so can't be force N, so that means it has to be the weight. And again, the head of the weight force needs to be touching the tail of the normal force. So this is your vector polygon. Oops. Vector polygon. So this is your answer. Does anyone have any questions about this one? So to summarize, we just thought about logically what forces are acting on the roller. If this was a difficult problem for you, you probably just need to freshen up on free body diagrams and equilibrium, and you should be good to go. But this one should take you like 30 seconds to a minute on the exam. This is pretty much a free one, so we will move on to something a little bit more difficult, and I actually have not done a video on this one yet. So you all are seeing it here first. So this one is practice problem 20. This is another statics problem. So the question asks, select the location on the x-axis where an additional load must be placed in order to achieve equilibrium of the L-shaped bar. So again, let's go over what it means to be in a state of equilibrium. To be in equilibrium, that means the sum of the forces in the x direction needs to equal 0. And in this case, we will say anything going to the right is going to be positive. To be in equilibrium means that the forces in the y direction, the sum of the forces in the y direction is also equal to 0. And to establish our coordinate system, we're going to say it's a positive y value if it's going up. Equilibrium also says there's no torque on the object. So the sum of the moments about some point also needs to equal 0. And right hand rule. So if you take your right hand, you always want your thumb to be pointed towards you. Always use your right hand. Your thumb facing you. If you curl your fingers, that's going to be positive. So we're going positive in the counterclockwise direction. So if we're going counterclockwise, we'll consider that moment to be positive. And I know statics and equilibrium is not the easiest subject for everyone. Physics really is not. It's physics classes are always the weed out classes in engineering. So if you have any questions about this, please let me know. Because this is very fundamental to understanding statics and then dynamics and other mechanics topics. So now that we've established what it means to be in equilibrium and what our coordinate system is, let's go ahead and start solving. So the problem is basically telling us that there's going to be a force acting somewhere on the x-axis. So we're going to have a force of some magnitude. Let's call it z. We're trying to find z. Let me move that over so you all can see. So we're trying to find not only the magnitude of z to keep it in equilibrium, we're also trying to find where it is at on the x-axis. So we're trying to find its distance on the x-axis. So let's go ahead and sum the forces in the x direction, because that is one state of equilibrium that we need to satisfy. So the sum of the forces in the x direction is equal to 0, and it's positive if it's going to the right. So I see this is acting in the x direction, and there's going to be some component of this force here that is in the x direction. It also has a y component. Let me label these. So the forces acting up here are going to be at location A, the force here is going to be at location B, and the force here is location C. Okay, so at location A, we have a force of -6 pounds acting to the left. So because it's acting to the left, it's going to be negative, and it's going to be a -6. The force at location B doesn't have an x component, so there's nothing we need to account for there. But force C does have an x component. So what is the x component? It's going to be the magnitude of C, which is 10, times 3/5. And where am I getting that from? Okay, so we have force C here, right? But it also has its own components. So let's make this dashed. So there's a CY value, and there's a CX value. We're told that this is a 3-4 triangle, which means the hypotenuse is 5. So if we want to find the x component of C, here we need to multiply it by 3/5. All right. And then we also know that there's some force Z that we're trying to find that may or may not have an x component. But all of that needs to equal 0. So let's go ahead and simplify this. -6, or 10 times 3/5 is what? It's 6. So we have -6 plus 6 plus z x equals 0. The 6's cancel. So that means our z force does not have an x component. So it's going to be somewhere along the x-axis going up or down, but it's not going to be doing this or this because it doesn't have an x component. Okay. So now that we know it has a y component of some sort, let's go ahead and sum our forces in the y direction. We know positive is upwards. All right. So where do we have positive, or where do we have y values on this L-shaped bar? We have one here. Okay. I was shooting for an oval. All right. So we have a y force there. We have a y force here. And we have a y force here. So we need to make sure we account for all of those in this problem. So starting off with the y force at point A, it's going to be a positive 6 pounds and it's positive because it's going up. So 6. At location B, it's going to be negative 10 pounds because it's going downwards. The y value for C is in the up direction, so it's going to be positive. It's going to be a positive 10 times 4 over 5. Because again, you're looking for this right here. So it's a 3, 4, 5 triangle. So you multiply by 4 over 5. And then we know our z force also has a y component. And all of that needs to sum up to be 0. Hey y'all, if you're joining on TikTok, I am having technical difficulties. So I dropped the YouTube live link in the chat if you all want to join on YouTube live and see my screen. All right, so let's go ahead and simplify this. So we have 6 minus 10, we know that's negative 4, plus 10 times 4 over 5, that's going to be 8, plus zy equals 0. So if you simplify this further, we're going to get zy equals positive or negative 4. What do you guys think? It looks like we have about 5 minutes left. So I'm probably going to work through this a little bit faster. So zy is going to be negative 4. And because it's negative, in our coordinate system, we know a negative value means it's going downwards. So zy equals 4, and it's going down. So we know z of y is moving down, but we don't know exactly where it's at along the x-axis. So let's satisfy our final condition, the moment equation. So we know the moment. Let's take the moment about point A so that we don't have to figure in these components here. Because if you're taking the moment about some point, any forces going through that point, so going this way, their line of action is going through this point, which means we don't need to calculate their moment at that point. Okay, so the force at B does create a moment though. We're saying counterclockwise is positive, taking the sum about point A. So if B was the only force acting on this L-shaped bar and we held it in a fixed position at A, it's going to turn this L-shaped bar this way. So it's going to turn it clockwise. So we know that the moment for the force at B is going to be negative, and it's going to be a negative 10 pounds, and a moment is force times a distance. So it's the distance of the line of action from the point of which you're taking the moment about. So It's going to be one, oops. It's going to be 1, 2, 3 feet away from A. So we have 10 pounds times a distance of 3 feet, and it's negative. Let's calculate the moment for the C components. So for the C of X value, again, if we held the L-shaped bar in a fixed position at point A, and it was only the C of X value affecting the L-shaped bar, it's going to turn it this way, which is positive. So it's going to be a positive. The C of X value, once again, is 6. So it's going to be 6 pounds. And then because this force CX is acting in the horizontal direction, it's going to be, we're going to calculate the distance from A going upward. So 1, 2, 3, 4, 5. So 6 pounds times 5 feet. And last but not least, let's do the same thing for the CY value. Let me just erase some of this stuff. Okay, so the CY value, it's also going to turn the L-shaped bar this way. So it's going to be a positive. The Y component for the 4C was 8 pounds. We found that here. So 8 pounds times 1, 2, 3, 4, 5, 6. So times a distance of 6 feet. And then we know Z of Y is acting downwards. So if it's acting downwards along the x-axis, it's going to turn the bar this way, which is negative. It's going to be a negative moment. So negative 4 pounds. And we don't know its distance because we don't know where it's located along the x-axis. So that equals 0. So if we simplify this, we get negative 30 pound-feet plus 30 pound-feet plus 48 pound-feet minus 4x equals 0. The 30s cancel. If we simplify further, we get 48 equals 4x. X equals 12 feet. So what we just determined was that there's a force of negative 4 pounds, which is ZY, acting at X equals 12. So we have to have that force there to make sure that the L-shaped bar stays in equilibrium. So that's all I had for you all today. I know we're over time a little bit, but do you all have any questions over any of the problems we went over? Any suggestions for next time? I'm very open to feedback. Feel free to leave it in the chat or DM me. Hopefully we'll have the TikTok live situation figured out by tomorrow when I go live again. But yeah, that's all I have for you all today. Again, I haven't posted practice problem 20 yet, so we all just did this for the first time together. So thank you all for joining the live session. And I'll be posting a video on practice problem 20 sometime this week on TikTok, LinkedIn, Instagram, and YouTube. Ooh, that's a good idea, America. I will work on that. I may not have it ahead of time by tomorrow, but next week I think that would be a really great idea just to have the practice problems ahead of time. So yeah, thanks for that suggestion. I'll let y'all know where you can download that some other time, or I'll post about it on TikTok or LinkedIn. All right. Well, thank you all so much for joining today. Yeah, please let me know if you have any feedback because I want to make this as helpful for y'all as possible. So, yeah, I will see you all tomorrow at 3. I hope you enjoy the rest of your day, and I'll talk to y'all later. Bye.